On our first slide here, why do we need fertilizers? So lots of people think that their soil needs fertilizing, but you know, if you're going to do it, it's usually because there's at least one nutrient that is lacking that would help support plant growth. We're going to talk about all of these different nutrients today, and we're going to also cover and understand, you know, what it takes to raise the background levels of fertilizer so that everything is being met for your plant needs. A lot of people think that fertilizer might consist of nitrogen, phosphorus, and potassium, but actually there's a whole lot more that goes into it than that. And at any time, if you guys start to feel overwhelmed with what we're doing tonight, please again, go ahead and start putting in some questions into that chat window, and hopefully some of those will get covered as we go. If not, I can just quickly glance over them at the end. And one of the things I want to make sure that everybody knows is that when we talk about fertilizers, we're not just talking about a set standard fertilizer regime that will match for all plants in all places. If you've got a lot different soils than someone else, maybe from someone in Southeast versus Fairbanks, or maybe if you're on the coastal area in Kodiak, if you're in the interior in Palmer on the Kenai, yes, there are differences both in climate and soils. And then what we do is when we think about fertilizing is matching things to the correct crop. So a lot of our crops have different needs: beets versus lettuce, cabbage versus corn, all sorts of different things. So we're going to talk a little bit about that as well. And of course, before we get going into anything, always remember, don't add too much fertilizer. You might think it's a good idea to add a lot of fertilizer up front, but really you should kind of minimize that as much as possible. And then we can come back in and add later if we have to. And of course, sometimes if we use too much fertilizer, we can actually do harm to our soil, and it can create conditions where no plants will grow. So we want to be very careful with how we do that. So if you're running your own garden or your farm and you're wondering, how the heck do I know if I need fertilizer? You're not going to just intuitively know. You can't tell by looking at the soil. You can't tell by picking it up and moving around in your hands. There is no way to know how much fertilizer is needed in your soil just by looking at it. Two things that you can do is look at past soil tests, check those out, look at the numbers. If you've got your records of what you've done since then to add fertilizer, you can actually account for a lot of the fertility needs for your garden by doing that. One of the other things that you can do too is by looking at how your plants grow. So if you notice that your plants aren't growing very well, or they seem to have disease or growth problems like discoloration, small leaves, not a lot of biomass produced, all of those things can be taken into account to think, well, maybe I don't have the proper soil fertility. And then when you do all those things, you might also be thinking it might be a good idea to take a soil test. And taking a soil test will average right around $20. You can sample from a few other areas to mix it together to send off, and it will give you a general idea of what your soil has in it so that you can actually specify and prescribe a proper amount of fertilizer. So if you've done that, you've looked at your records and you've actually taken a soil test, you can interpret all of those things to come up with the demand that your crops have so that you can develop an amount of fertilizer to add. And you can do that yourself if you've got some practice, or you can contact somebody in Alaska. It would be University of Alaska Fairbanks Cooperative Extension Service can help you with coming up with soil test interpretations. Your local soil and water conservation district may also be able to help you with that. Regardless of how you do it, just make sure you've got some knowledge behind how you're going to apply your fertilizer. Some of those things we're covering tonight, so that will help you too. And then when you get done thinking about what you're going to apply, you need to choose the best source for your fertilizer. So we're talking organic versus conventional fertilizers. And we're also thinking about what's available locally versus what we might want to have shipped in. And your choices are going to be based on your own costs, the efficiency that you see in the fertilizer that you might choose, all of the science behind the different types of fertilizers. And then also what you're going to be doing is basing that on just a choice of how you run your garden or farm. So if you know for sure that you're not going to use any conventional fertilizers no matter what, you just want to go completely organic, then you know right off the bat what you're going to do. And then also when you do your fertilizer applications, you want to make sure you do it in a careful and methodical way. This is very much like cooking. If you add too much of one thing, it might taste off. And for your plants, of course, they're not tasting the soil, but they are using it in specific ways for growth. And if there's too much of one thing, it can offset and affect how it absorbs other nutrients. So as I talk about this, it all sounds easy, right? You look at a soil test, keep your records of what you've added in fertilizer before. You kind of know what your crops need, and you can just go out there and start adding fertilizer. Well, as you'll see as we go over this for the next hour or so, that it's not entirely that easy, and that might be part of the reason why you're here tonight. So, like I said, it's not necessarily easy, but when you do it right, it's going to help control disease. Because if you've got a lot of plants producing and maybe they're growing a lot of vegetation, but they're not growing the right amount of root biomass, that can affect how quick the plants grow. It can affect how interspersed the leaves are together, and it can actually affect the disease. And also, if you fertilize but don't over fertilize, and you kind of keep it where the plants need it, you're going to help control your weeds. And then for water quality, of course, adding too much fertilizer could affect water, especially groundwater and surface water that might go other places. So we want to make sure we minimize that as much as possible. And in general, when you add the right amount of fertilizer to the right places, you're going to have healthier plants. Your production is going to be improved. You may notice a significant increase in the quality and taste of your produce. And then also you might save money. So let's go ahead and start working with fertilizers. We'll hold your horses. We actually need to check one thing first. We need to look at pH. pH is something that's super important, and it affects the way that nutrients are available to plants within the soil. We went into a little bit more in depth about pH and how it's interpreted on a soil test during the last presentation. And again, that's on YouTube if you want to review that. So pH, this is the very first thing we want to do. If we're going to change anything, we want to make sure pH is right so that we can adjust that first. First thing that we look at besides just pH is our organic matter. This helps us interpret whether or not our pH is high or it's low. If our organic matter is at 20% or above, in general, as long as our pH is between 5.8 and 6.5, it's okay. We don't really have to add a lot of lime to increase that. The reason that we're thinking about that 5.8, 6.5 is because if the organic matter was below 20%, you would want that pH near 6.5. Actually, somewhere near 6.5 all the way up to 7 would be ideal for most of our gardens and farms here in Alaska. If we think that we don't know what our organic matter is, that's one of those things that's reported in the soil test. You can tell a little bit by looking at it if it's got very much organic matter in it, but certainly you're not going to be able to tell if it's 15% organic matter versus 25. So a soil test is really helpful in determining that. And then once you know what your organic matter is, just knowing if your pH is at 5.6.5 or near 6.5, that will help you determine if you need lime. And the ways that you can calculate this without having to memorize it is we do have an online calculator that I've developed that will help you understand these numbers. So if you've looked at your soil and you've determined that you need to add lime, say that your soil was high in organic matter, but the pH was below 5, or you did a soil test, looked at it, you got a buffer score, your pH was at like 6.2, and you don't have very much organic matter, it's at like 7%, and you want to add lime because it's going to help your crops grow, well, then we need to know what that rate is. And I just mentioned that calculator will help interpret that for you, and it will come up with a rating for how much lime you need to apply. So right now, we're just going to assume that we know we need to apply lime, and we need to apply lime here in this example at 15.4 pounds per 100 square feet. Of course, 100 square feet is equivalent to a 10-foot by 10-foot area, or a 2-foot wide row that is 50 feet long. If we extrapolate that out to 1,000 square foot basis, that would be 154 pounds of lime. And if we extrapolate that even further to 1 acre, which is the equivalent to 43,560 square feet, that would be about 6,700 pounds of lime. So when would we apply this lime? Do we want to do it in the fall? Do we do it in the spring? Can we do it in the middle of the season? Well, in general, it's safe to apply the full rate in spring, and you're going to try and incorporate that and spread it evenly across the area. You can also do it in fall. Fall is actually ideal if you know you need to apply lime, because what's going to happen is when you apply it over the winter, we will get some precipitation, and then early spring we'll get some snow and ice thawing and melting and moving through the soil, and that will help break up that lime and have it react with the soil to change the pH. If we wait until the spring only, it's not going to have as great of effect, and the pH will start to change throughout the whole season, and it won't be perfect right at the beginning of the season, but that's okay. As long as we do lime, it will help as the plants grow. So how do we apply this to make sure we're doing an even spread? So if we assume that we needed to apply that 15 pounds per 100 square feet, or that 150 pounds per 1,000 square feet, what we're going to do is calibrate a spreader, and it can be a drop spreader, hopefully, or it can also be one of the whirlybird twirling spreaders that have the little spreader underneath that flings it to the sides. Those spreaders that fling it to the sides work better with prilled lime versus powdered lime. But either way that you're thinking about this, you're going to apply half of the total amount to your area going in a north to south direction, and then the other half coming back going east and west. You can see in the right hand photos, we've got myself there moving one direction, and then again applying it at a right angle. And by doing that, you're going to make sure it's as even as possible, and you're not getting lines of lime that are higher and lower in different areas. When you do this, you're going to want to make sure that you have protective eyewear of some kind. It can get in your eyes, especially if you're using powdered lime. And you're also going to want to wear gloves because you'll be handling the stuff. And if you can, like I said, you want to use a drop spreader. So after you've put your lime on the ground, you're going to come back and you're trying to work it into the soil. If your lime is just sitting on the soil surface, it's going to take some time to move through. And then if you have any slope to your land, some of that could get carried away with surface water and heavy rains. So working it into the soil is going to give you the greatest and fastest effect to change your soil pH. And when you do so, you're going to try and do it at a zone 6 to 8 inches down from the soil surface. Why do we do it there? Because that's where most of our plant roots are growing. If for some reason you've noticed that you do need magnesium in your soil, you can use dolomitic lime instead of just regular agricultural lime. Dolomitic lime has about 10% magnesium in it, and that will bump up your magnesium numbers. For most part, magnesium is usually not needed in the amount that we have to use all of our lime as magnesium dolomitic lime. We can actually usually come in at about 20% to 25% of the lime that we include as just dolomitic lime. So dolomitic lime is usually more expensive, so we want to minimize over using it. Plus, we don't want to have too much magnesium in the soil. And the other thing that we need to think about is try not to apply lime, especially when it's powdered lime, during wind and rain events. It's going to affect the movement of the lime through the soil, and it might not end up in places it needs to be, and you don't want to get lime all over you and in your eyes. So when we've applied the lime, what we need to be thinking about, if you've done it in the spring, you can also apply fertilizers immediately prior to tilling it in. We're going to talk about fertilizers here in just a moment. But if you have applied lime, it is okay to apply some of these fertilizers with it in the spring and incorporate it. Many of us are using a rake or a rototill to put it in, so that's just fine. But if you're going to apply your lime in the fall, it's best not to apply your fertilizers during that time, because what's going to happen is that some of that fertilizer is going to degrade, and it's going to get washed away or leached away, and it's not going to be fully available in the spring when your plants need it. It really just makes the most sense to apply it in the spring, so it's right there and unspent by the time the plants start growing. So if you think that adding lime is difficult, adding fertilizers is a lot more complex because you're going to be looking at many different numbers and doing a bunch of calculations. So we're going to talk about that now. So when we add fertilizers, what we need to know is what's in the fertilizer. So If we know what's in the fertilizer, that helps us determine how much of it we need to add. And it determines a lot of the pounds needed per acre or the pounds needed per 100 square feet. And you're going to get those numbers from your soil test. And before you really get to the point where you're going to put anything in the ground, you will have decided your sources already. And like I said earlier, this is a lot like cooking. So there's many different types of ingredients that you could use for fertilizer. You need to choose the ones that work best for you, that meet your budget, and then also fit your standards for what you want to use as fertilizer. So let's talk about our fertilizer sources. We have conventional fertilizers. These are considered non-organic or inorganic fertilizers. They're usually used on large scales. So if people are doing a lot of lawn fertilization or large pastures or doing hay, usually they're going to choose a conventional fertilizer because they're not eating it directly themselves, and there's not as many benefits to using organic fertilizers. However, for growing produce, a lot of people will choose organic fertilizers. Usually we use these on smaller scales. Some of the availability may be less, or they may be a little bit more costly to have them shipped in or purchased locally. For any of you that might be organic growers who actually sell certified organic produce, you're going to want to make sure that your fertilizer is cross-checked on the OMRI listing. I can show you guys how to find this here after we end the presentation tonight when we take questions. It's pretty simple. You can go into Google, type in OMRI list, and it will have a section there where you can do a search for fertilizers, and it will tell you which ones are certified organic that you can use for organic growing. And of course, if you're just growing things at home, you don't need to worry about whether or not it's certified, as long as you know it's coming from a relatively organic source. Of course, green manures and cover crops, including those that have legumes, are really great to use as a fertilizer base for your soil. It's going to increase your organic matter, and it's going to increase the number of nutrients that are available to your plants. So a cover crop mix that might have turnip, barley, or wheat or rye as a grass, maybe buckwheat, and then also a legume such as a pea would be something good you could grow. And we've got actually a cover crop mix right here in this photo to the left. That's my daughter walking through our cover crop mix last year. And you can let it green to get the full flower like that, mow it down, and then after it's been mowed, you can till that into the soil. And what that will do is it will feed the soil that organic matter, and it will decompose over the winter, and it will make your soil improved for next year. If you do this early in the spring, you can actually have enough time for it to degrade a little bit for about 2 weeks. Then you could come in and plant it again with a relatively short duration crop. And just from doing thousands and thousands of soil test interpretations here in South Central Alaska and Kodiak, I can tell you that when people look at fertilizers, about 80% of the people I have asked for help want to know how they can do it using organic fertilizers. So there is about 20% of folks that are using conventional fertilizers, but about 80% of the folks I've talked to in Alaska choose organic. So here's a list, and it is a big list of conventional fertilizers. Again, these are the ones that are not considered organic, and most of these are going to be used to meet nitrogen, phosphorus, and potassium needs. So when you see that N, P, and K up there, that's what that stands for. Over on the right, it says S, Ca, and Mg, that's sulfur, calcium, and magnesium. So when we look at that top conventional fertilizer on the left, it says urea. It's 4600 in parentheses. That's the NPK rating. So that means by weight, this urea fertilizer is 46% nitrogen, 0% phosphorus, and 0% potassium. When we look at the sulfur, calcium, and magnesium rating, those are 0%, 0%, and 0%. That's the same methodology for all of the listings for all of the fertilizers here. We're actually going to go through and look at a lot of these. And what I'd like you guys to think about as we do this is not necessarily memorize all of the numbers here, but just notice there's a large number that are available. And if any of us are using conventional fertilizers, most of us will choose something that's already pre-mixed. So something that's like a 10-10-10 or a 16-16-16. So, but these are the main fertilizers that go into those mixes. So looking at our conventional fertilizers for nitrogen, the best sources, if we were going to look at them, would be urea, ammonium nitrate, sulfur-coated urea, ammonium nitrate sulfate, ammonium sulfate, diammonium phosphate, ammonium phosphate sulfate, calcium nitrate, potassium nitrate, and monoammonium phosphate. These are all available. What you will notice is that I've ranked them in general from being high in nitrogen at the top to being lower in nitrogen towards the bottom. So if you were thinking that you were going to develop your own fertilizer regime using conventional fertilizers and supply nitrogen exactly the rate you want to, these would be the ones you'd be looking at. If we're looking at conventional fertilizers for phosphorus, the ones that we could be looking at would be triple superphosphate, single superphosphate, monoammonium phosphate, diammonium phosphate, and ammonium phosphate sulfate. These here, again, ranked from relatively high in phosphorus towards lower. The two on top are mostly phosphorus. You are going to have some calcium in there. When we go down to a monoammonium phosphate and diammonium phosphate, you're actually getting nitrogen and phosphorus in those. And that ammonium in those is where you're getting the nitrogen. Conventional fertilizer for potassium sources, these four here, including potassium chloride, potassium sulfate, potassium nitrate, and potassium magnesium sulfate, are the ones that are used quite often. When we look here at the ranking of how much potassium is in it, you can see potassium chloride is very high. And then as you get down to potassium magnesium sulfate, that's relatively lower. And depending on what you need, you can see that there are other things usually included in this besides the potassium chloride. Potassium chloride is just potassium and chloride, so you're not seeing anything in terms of nitrogen, phosphorus, calcium, magnesium, or sulfur. When we move on and look at the types of organic fertilizers that are out there, there's even more options. That's because there's a lot of organic sources that could potentially be used. And when those organic sources are looked at, we can know that there's many choices, and some are going to be very high in nutrients. Some of them are going to be relatively low. Some of these things are actually relatively cross-listed as conventional fertilizer because it depends on the sources that they're coming from. So if we look at potassium sulfate here for organic fertilizer, there are some potassium sulfate sources that we could use for potassium that would meet the organic listing. A classic example would be this potassium chloride listed here, the second down on the left, which is also named sylvanite. So this is a naturally mined substance that has a lot of potassium in it that you could use and be listed as organic. Again, all of these items, if you are truly wanting to make sure that they are listed as organic and can be registered for organic growth, and you won't have any problems being certified, you need to make sure they are OMRI listed and you have a label to come with those when you use them. Again, there's a large number here. I'm just going to quickly go through these individually representative of the different types of nutrients that they provide. So for organics, the types of nitrogen sources that most commonly are used, we're looking at things like feather meal, blood meal, fish meal, bat guano, cottonseed meal, whitefish bone meal, salmon bone meal, fish emulsion, compost, manure, alfalfa pellets, bone meal, beach peat, and I didn't put it on the list because the ratings vary quite widely. You could also use fish waste. People do use fish waste from fishing here in Alaska as part of their organic nutrients. So I listed all these again, ranked from relatively high in nutrients at the top to relatively low. One thing you will notice is that things like feather meal and fish meal are going to be slower to release to plants than something like blood meal. Blood meal dissolves with water quite easily, moves through the soil quite easily, and is readily available to plants. So one of the top ones that I recommend for people looking at nitrogen is blood meal because it's relatively high in nitrogen, it's organic, and is quickly available to plants. Something else that people might use as you look a little further down the list is something like fish emulsion. That's a 5-1-1 when we look at NPK for fertilizer. So it's going to have a little bit different regime. You're going to need to come in with phosphorus and something else with potassium to meet all of your plant needs. Organic sources for phosphorus. One of the best ones that folks will use is bone meal. Salmon bone meal also works, as well as whitefish bone meal. Fish meal in general, this can be listed as many different things, but it's not really including the bone so much. It's mostly going to be a mix of other stuff in there, and that's why we see with fish meal, it's going to have a little higher nitrogen rating. Bat guano, again, cottonseed meal, of course, compost and manures again, and then rock phosphate. I've listed rock phosphate here just because people have commonly thought about it and used it. I generally will not recommend rock phosphate, however, though, because if we think about its rating, it's a 0.30 on the scale of NPK, and even that might not be available so much here in Alaska with our cooler soils. So that means you'd have to add literally tons and tons of rock phosphate to try and get your phosphorus needs. And actually, even if you had only rock phosphate as your soil, it's going to be very hard to get your phosphorus needs met. So what we do is we look at other phosphorus sources, and if you do want to include rock phosphate, you can do that on your own and add that as a part to change the texture, profile, and the way your soil is, but realize that a lot of your nutrients are going to have to come from something that's more concentrated. Looking at organic sources for potassium, again, we have that sylvanite listed here, potassium sulfate, langbeinite, which is one of the favorites for folks to meet all of their sulfur, potassium, and magnesium needs. Wood ash is used relatively hesitantly. It does have a fair amount of potassium in it, but it will raise your pH, and it does contain sodium. So when you ever think about all of the things that you can add to your soil, sodium is not one of them. So I usually don't recommend wood ash unless it's planned to be a one-time use, because that sodium will stay in the soil for a long time. Compost and manure, again, are good sources, and we'll talk about that again here in a little bit. Soybean meal, kelp meal, seaweed, beach peat, cottonseed meal, corn gluten meal, and green sand. Green sand is very heavy. It's hard to ship to Alaska to get very much of it, and it is very low in potassium. It's been found in recent studies that the potassium actually listed on what they sell you is actually far lower when you end up with it in your hands. So there are many other sources of potassium that are better. And of course, if you do want to add the sandy texture to your soil, you could use just add sand to your soil to do that. But I would not rely on green sand as your source of potassium. There's many other good organic sources. Things like beach peat, seaweed, and kelp meal are low in potassium, but they do provide other things. You can see that we've got beach peat adding copper, zinc, and boron. And what beach peat is if you're on Kodiak, you can collect it on the coastal line there at high tide. And it's a mix of spruce needles and little twigs and shellfish shells and everything that's come up with the high tide. And it's quite good for an amendment for your soil. But also things like kelp meal and seaweed also have things like copper, zinc, and boron in them. When we look at other things that aren't just NPK, there's other organic fertilizers out there. They include elemental sulfur, gypsum, as long as it's been naturally mined. Again, compost and manure, and those provide a lot of things. Compost and manure will have the metals in it, so zinc, copper, and all of the other things that we need like boron. Beach peat, again, I've listed it here as kind of an other. Epsom salt, which is magnesium sulfate, Those can be used. And borax. So borax is a mine source for boron. You can get it in two forms. You can get it as regular 20-team mule team borax, which is 11% boron, or solubor, which is about 20% boron. And then, of course, you could use dolomitic lime that has about 10% magnesium. Looking at compost and manure, compost vary very widely. So those numbers are going from very hot in nitrogen to low in nitrogen, depending on the age and depending on the animal. In general, if you just think about compost, they're going to have about 2 to 3% nitrogen, probably about a 0.5 to 1.5 phosphorus in it, and probably somewhere between 1 and 2 for potassium. They also are going to have things like copper and zinc and boron, like I mentioned earlier. That's because when we think about plants and then also manures, those things accumulate in the organics of the material that was grown. So whether it was plant matter or all of the plant matter that was digested with other things the animals may have eaten, it just concentrates it in that manure and compost. Chicken manure is one of the ones that's the highest in nitrogen. So if you're looking for a lot of nitrogen, chicken manure would be there, but also a lot of these manures and their use depends on your availability to them. So if you have your own animals, you may already have manure on hand that you would use. Of course, it's always better to compost your manure with plant matter and to end up with a finished compost rather than just using straight manure. But you can use manure in your garden. You just want to make sure you're going to meet all of your produce safety rules for E. coli and things like that. In general, a little bit of an aged manure could be better. And of course, if you're growing food for consumption and sale, you're going to want to work with the DEC. Then, of course, our produce safety people in extension to make sure you're keeping the E. coli and contamination concerns down to a minimum. When we look at sheep manure, it's kind of a mid-range with everything that's in it. It does have a relatively high level of nitrogen, though, compared to swine and horse manure. Cattle manure is one of the best ones that you can choose to use for manure because it's mid-range and nearly equal for all the things that's in it. It does have a good amount of NP and K in it, and it has copper and zinc. If you're looking at something like worm castings to use, it does have a little nitrogen in it, and it will have a little phosphorus and potassium, but it will be near zero for those, and it's quite variable depending on the diet that those worms were eating in addition to the soil that they were growing in. And then, of course, there will be some trace minerals in there as well. And one of the things that's not listed or talked about on here is, yes, there will be biological material in there for microbes, both fungi and bacteria that will be present in all of these things after it gets added to the garden and as it's being shipped. So when you think about those things and adding it to the garden, yes, they will be becoming alive pretty quickly because they are high in organic matter. Other types of things, if we're looking at aged manure, that's something that we can use and not have to worry about nitrogen burn. Nitrogen burn is one of the things we worry about the most when we think about compost and manures. Aged materials that have weathered outside, that means they've been rained on and been leached through. And then also the microbes have been sitting there digesting a lot of what's there and using it up and converting it so that it's not all super hot and put on your plants and in the soil. So aged manure is great for increasing your organic matter, but it's not going to have a lot of nutrients in it. It does become something that becomes quite variable the further and further it's aged, but something that's 2 years old, you should pretty much assume that it will have almost no nitrogen in it, especially if it's been open to the elements. Now, if you did have manure and compost, you collected it, dried it, put it somewhere dark, dry, and cool, that will keep its nutrients much longer than if it has been outdoors in the weather. So now that you know what your options for sources are, how do you know how much fertilizer to add to the garden? So that's what we're going to talk about next. On this slide, you're going to see here that I've got a background of my online calculator. which just shows that you're going to need things like the sulfur, phosphorus, calcium, and magnesium, and potassium, depending on what's already available in your soil. This punches out a number that tells you just the amount of nutrients for each one of those that you need. And then below, it will help you determine what they are in terms of amendments that are commonly used. Of course, after we talk about things today, you can help develop your own plan of what you're going to add just by knowing what percent of nitrogen, phosphorus, or potassium or other that's in it. So if we're going to make estimates and we're going to go ahead and use something simple like the calculator, what we're going to do is take a list of the options that are available on that calculator and choose the one that works best for us. For some of us, it's going to be the one that requires the least amount of pounds of fertilizer. Some of us, it's going to be whatever we have on hand. And then for some of us, it's going to be whatever costs the least. So if we're looking at this chart on the right and we see potassium listed, we can see that there's a few different sources listed for potassium. And depending on which one we choose, it drastically affects the amount of pounds that we need per 100 square feet or 1,000 square feet. So for organic options, this will tell you right away. So you really don't need to do a lot of work. As long as you have numbers from your soil test, it will tell you what some of these common things you need in your garden. If we're looking at conventional, again, on that calculator, you can just look at that and it will tell you what the best match is for only nitrogen, phosphorus, and potassium. This calculator uses the amount needed for both nitrogen and phosphorus as the main predictors for this. And for whatever reason, the soil test that was used here as an example showed you that you need something that have equal ratios of nitrogen, phosphorus, and potassium. So things like the 10, 10, 10, 16, 16, 16, and 20, 20, 20 were the best options. Of course, that's found out by looking at the percent match on the left. How do we know what's in all of these fertilizers and what do these numbers mean? If we look at the chart over here on the right, we've got a little image and it shows 21, 3, and 20 listed on a fertilizer bag. And of course, right below each one of those numbers, there's a number or a letter representing N, P, and K. For this fertilizer tells us that it's got 21% nitrogen in it by weight. And since it's a 50-pound bag, it's got 10.5 pounds of nitrogen in that bag. For phosphorus, it's listed as 3%. And for that 50-pound bag, that's going to come out to being only 1.5 pounds of phosphorus. And because of the 20 is relatively high for a 50-pound bag, it's telling us it's actually going to have 10 pounds of potassium in it per 50-pound bag. So when we add that all up, the 21, 3, 20 is going to tell us we end up with somewhere right around 22 pounds of fertilizer for a 50-pound bag. And so if you have high fertilizer numbers on the bag, something like a 20, 20, 20, it's going to mean that you have 60% total fertilizer as nutrient in that bag. But if it's something low like 555, only 15% of that bag would be fertilizer. And of course, notice on this NPK that you don't have any other numbers listed. That means things like copper and manganese, sulfur, magnesium, calcium, all those other things that you might want are not included in this fertilizer. So even if you choose a conventional fertilizer, you will have to come back in and usually amend with something else. So how do we use our fertilizer prescriptions out in the field? When we come up with a rating of how many pounds of fertilizer we need to use, or we know how much pounds of amendment we need to use from the calculator, we need to have some kind of scale to measure it out, because fertilizer is measured in percent by weight. So we need to know how many ounces or pounds or grams to use. And so you can just use a regular kitchen scale that's in ounces for small farms and gardens. If you're using on larger properties, you're going to want a dedicated scale that can measure up to about 5 pounds or so, or 2 or 3 pounds when meeting out your fertilizer needs. And then when you're working on something even larger, you might need a heavier scale, and then you can use things like pails and buckets to separate things, and maybe even totes. But when you're working on those small scale zipper bags, work great for trying to put all of your prescribed fertilizers and get them ready for each plot area in your garden. So when we come down to the actual calculations and say we're doing this on our own, we need to determine the amount of area that we have in our garden. So for our farm, it's usually going to be listed in acres or thousands of square feet. For our home gardens, it's usually going to be in the hundreds of square feet. If we're looking at lawns and flower bedding areas, it might be thousands of square feet. And if we're looking at much smaller areas, like things on our backyard with just garden beds, raised beds, containers, or hanging baskets and things like that, we're usually looking at quantities far less than 20 square feet. On large farm areas, when we apply it, it's usually going to be applied via spreader, or it's going to be coming out of a sprayer when mixed with water. And those things are quite common on our larger properties. If you're doing either one of these, of course, you're going to need to calibrate all of the spreaders and the sprayers before you use them, and be able to properly weigh out the ingredients and mix them when you put them into the vehicles when you transport them. So let's get down to actually calculating how much to add to our garden. So all of our different areas that we work with are going to be shaped differently, but most of the units we're going to be using are square feet. So up in the upper left-hand corner, we have a 10-foot by 10-foot square garden area, and that comes out to being 100 square feet. The way we find that area is simply just length times width. The next thing down that we see there is we've got a row. So usually we'll have either a level row or a raised row in our garden. This one happens to be 2 feet wide and 20 feet long, which gives us 40 square feet for area. The next one, we have a little bit larger raised row at 3 feet wide and 50 feet long. That gives us an area of 150 square feet. Down in the bottom left-hand corner, you can see a little blue circle. It's 6 foot in diameter. And one of the numbers we need to know to calculate the area is radius. So we know that a circle with a 6 foot diameter has a radius of 3, because 3 plus 3 equals the diameter, which would be 6. So knowing that its radius is 3 feet, we can apply that with the number pi, which is 3.14, and times that by 3 to the square root, or 3 squared, sorry, to give us the total area of 28.3 square feet. So if you thought of a 6 foot diameter container, it's going to be 28 square feet. If it had been a 6 foot by 6 foot square rectangle, with a little larger area, it'd have been 36 square feet. So regardless of what you're working with, you just need to be able to calculate what the square feet is so that you can properly apply your fertilizer. So let's look at an example. So if you guys are going home and trying to use some of these things that we're talking about to work for you, if you come up with your prescription of needing 2 pounds of 16-16-16 fertilizer for your 100 square feet of garden to meet your N, P, and K needs, you're going to look at how we apply it. So for a 40 square foot area, you're going to divide the 40 square feet by 100 and multiply it by 2 pounds. And if we do that right there in that equation, you can see I've written it out. It comes out to being 0.8 pounds of fertilizer needed for the 40 square feet. And that's if we had a conventional fertilizer which had an equal amount of N, P, and K in it. But for some of us that are not using conventional fertilizers and it's not so easy, we actually have to calculate each one independently. So for our organic garden, where we can't just use a conventional fertilizer, we need to establish the nitrogen. So looking here, and we've got a small area, it's 25 square feet. And we know that we need a rate of 2.9 pounds of blood meal per 100 square feet. Well, how do we make that work for a 25 square foot area? You just take 25 divided by 100 and multiply it by that 2.9 pounds. And that gives you the 0.73 pounds of blood meal needed for your 25 square foot area. And that covers your nitrogen needs. To cover your phosphorus needs, we had a recommendation of using 2.1 pounds of bone meal for 100 square feet. But since we only have a 25 foot area, you're going to divide that by 100 and multiply it by 2.1, which tells us we need 0.53 pounds of bone meal. Looking again at our potassium needs, it's the same methodology here. We saw that we needed 1.1 pounds of Epsom salt if we had 100 square feet. But since we don't, we have 25. We're going to divide that by 100 and multiply it by the rate of 1.1 pounds, and that'll give us 0.28 pounds of Epsom salt. If we're looking at a conversion example here and say that we know that we have a certain rate of pounds per 100 square feet or pounds per 25 square feet, like we did and we calculated in that last example. So going with that prescription of 0.28 pounds of Epsom salt per 25 square feet, how do we convert that to ounces? Well, you're going to look down here, and 0.28 pounds times 16 will give you 4.48 ounces, or 4.5 ounces needed for your 25 square foot area for Epsom salts. So you don't necessarily have to use pounds. It'd be a lot easier for some of our scales to use ounces. So converting it like that will help you. If some of us have a little bit smaller scale, or we have a gram scale, you can also convert it for that. 0.28 times 454 grams per pound, and that would give us 127 grams of Epsom. Fertilizers that we can add with water, it becomes a little bit more complicated because we're going to be adding a unit of fertilizer to a unit of water, and then we're going to apply that to a set unit of square feet of our garden. The most common one that people will do in Alaska is add boron, and the standard rate for that to raise your soil levels about 1 to 2 parts per million per 100 square feet is 1 tablespoon of borax diluted with 1 gallon of warm water per 100 square feet. If we're looking at converting that down to just a 25 square foot garden, that's going to be just 1/4 gallon of solution. And the way we apply that is you can use a watering can, or you can use one of the small handheld or back-held sprayers and apply that to the soil and not the plant leaves. When we look at fertigation, things become more complicated. If you're a person who's organically minded, the concentrated nutrients that are available for hydroponic systems and fertigation systems that you can buy are not considered organic. These are inorganic concentrated nutrients that you apply to water, are considered sterile. There can be contamination free, and there's many reasons for that for food safety. And so that's what you'll be applying. So just know that that's the case. If you are wanting to make your own mixes like compost tea and other things like that, those vary widely in the amount of nutrients that are actually there. And so you're just going to be guessing at the amount that you can add for your plants. And without a test, you wouldn't know exactly how much your plants would need. But they can be used as a way to fertigate with some nutrients in water. When we're thinking about compost, it's not easy to know how much to add because, like I said, compost can be quite variable. The best compost that you can get will actually have a rating and a test done on them to tell you how much nitrogen, phosphorus, potassium, and organic matter is in them. Those are very helpful. If you don't have any of those numbers, you really have to guess. So if you guys are making your own compost at home and it's a fairly large amount, like you've got quite a bit of compost, it might be worth having a test. If you guys have a small amount of compost, it might not be worthwhile to take a test. So there's some practical rules of thumb we can use to determine how much compost to apply. So when we look at some of the surveys that have been done rating the electrical conductivity, which is a measure of soluble salts in compost in Alaska, we can come up with a value of somewhere near 9 for EC values. In general, we like to see those numbers down below 2. So there is a fair amount of soluble salts in our compost in Alaska that we've put together here. So we need to use it fairly sparingly because we don't want to raise our soluble salts levels too high, because those soluble salts like sodium don't go away anytime soon. Practical rule of thumb is really don't apply more than 1 inch of compost per year to your garden or farm. If you have a perfectly done test that's been done on your compost and you know what's in it and it doesn't have a high soluble salt rating, you could get away more with it, adding more, but you would really want to then look at how much nitrogen, phosphorus, and potassium is in it to make sure you're not over applying one thing over the other. One of the things that that we've done is to make sure that when you're using compost, is that you're using it for all of the possible reasons. So if you're adding compost, remember you're also managing the organic matter. You're also managing things like copper and zinc. So if your soil is deficient in copper and zinc, but you don't necessarily need it for nitrogen and phosphorus, you might still apply compost because it does have those metals in it that will help your plant. Applying your compost, if we just take a standard sample, and so I actually took an example from one of the tests that I've seen, and it had a nitrogen level of about 390 parts per million in the compost. It had a phosphorus level of 211 parts per million, and then potassium had a rating of 923 parts per million. And all of your composts, depending on the source, will vary quite widely. So you could have one that's high in nitrogen, high in phosphorus, and low in potassium if it's been sourced from different materials. So based on that, and thinking that we're going to apply 1 inch of compost to our soil, and we've done a soil test too to know what's in our soil, and we know we're gonna go ahead and till in that 1 inch of compost into our garden right in the spring. Let's take a look at how that would affect our soil numbers. So if we're thinking about the nitrogen that was in the compost and the nitrogen that was already present in the soil, this is what happens when you apply it to that upper 5 to 6 inches of soil. So again, the nitrogen was 390 parts per million in the compost, and in the soil there was 10 parts per million nitrogen. The way we figure out how that will work when we dilute it with that upper 5 to 6 inches of soil, we're going to take that 10 parts per million and times it by 5/6, so 5/6. And then we're going to add it to 390 parts per million times 1/6, or 1/6. When we add those two numbers together, which is 8.33 parts per million plus 65 parts per million, it's going to give us a total nutrient value of nitrogen now added to the soil when combining soil and compost in the upper 6 inches of soil to be 73.3 parts per million, which is near ideal for most of our larger vegetable production. So having a value of about 75 parts per million in the soil is great. If we look at what would have happened if we added to the soil in terms of phosphorus, these are those numbers. Again, it's the same methodology and the same way we worked through there to get it. But when we looked at the total value, the addition of the compost with what was already in the soil, and since the soil already had 117 parts per million of phosphorus in it, it raised the total values in the upper 6 inches of soil to 132.7 parts per million, which is still good and is okay. If we look at the next example of how it will affect the potassium levels, because it has a lot of potassium in it, you're going to see that 923 parts per million already in the compost, when added to the 150 parts per million of potassium already in the soil, will increase the soil level in that upper 6 inches to 279 parts per million, which is almost double the needed requirement for potassium. And when we add too much of potassium, that's actually going to affect how calcium and magnesium are available to plants, because they're all three cations. So it's going to affect the proportion that's available to plants, and it could affect plant growth. So in this instance, while it met the nitrogen and phosphorus needs just fine by applying this 1 inch compost, we're actually oversupplying the potassium. So one of the things we could do is back off the compost and only apply about a 1/2 inch of compost, and then meet our nitrogen and phosphorus needs by coming back with some other type of organic amendment. When we apply manure, we're going to do the exact same strategy that we just used, and ideally it works best when you've got a rating for your soil test to know what's in the soil already and to know what's in your manure, because the manure testing can also tell you the nitrogen, phosphorus, and potassium that's in it. Ideally that would be great, but a lot of us probably aren't going to have that. So again, a lot of the materials that we use, things like beef manure or horse manure or even rabbit manure, are going to be fairly high in nitrogen, a little bit lower in phosphorus and a little bit lower in potassium in general. And if we're thinking about how much to add, probably not more than a 1/2 inch to 1 inch. And you're really just going to be guesstimating if you don't have a sample and know what's in it. So you could use a table and guess based on the numbers I talked about earlier. but your numbers in your local area could be completely different from that. So it is something you can add to your soil, and it is helpful, but you just need to just kind of guess that, make sure that you're methodical in the way you do it, and don't add a lot. Make sure you're using another source of nitrogen, phosphorus, and potassium to come back in with in case things aren't what they need to be. When we think about controlled release fertilizers, a lot of the big sellers these days are controlled release fertilizers. The thing to know about controlled release fertilizers is that they vary by temperature. So if your soil is very warm, as in a high tunnel, for instance, those controlled release fertilizers will release just fine in your soil and will release at a high rate over a shorter period of time. If you're using it in colder soils, like the soil barely gets to 60 degrees Fahrenheit, and you're using that outdoors, what's going to happen is that controlled release fertilizer actually is really going to release slowly, and it's not going to be available to your plants very quickly. And especially in the middle part of the season, it actually might limit the amount of growth that your plants grow. One of the things to consider too is some of the things I've been talking about is just on a square foot basis. You can apply it to one plant if you want. The way to do that is to determine how much area each one of those plants is taking up and divide the proportion of fertilizer down to that smaller area. So for peonies, for instance, plants that are spread apart, you might think that they have a area of growth somewhere around 3 to 4 square feet. And so you would divide the 100 square foot prescription down to meet that 4 square foot zone. If we're thinking about trees, whether they're small or medium size, you would also do the same thing, but you might be thinking about square foot areas of somewhere between 8 to 16 square feet per tree. And that will help you limit it down so you know what to apply to each tree, because you might not necessarily be working with a square foot, on a 100 square foot level. So that would be the way to do that. And then when you apply on a one plant basis, you never put it up against the base of the plant or the tree. You space it at least 4 to 6 inches away from the base of the plant, because it can actually sit, there aren't a lot of roots right there at the base. Those roots are actually made to grow and seek out nutrients further from the plant. So if you want a healthier, stronger plant, spread the nutrients a little further away from the base. And that actually takes us to the end of our presentation for tonight. One of the things I'll mention really quickly is that I didn't talk about side dressing fertilizer coming in later in the season. One of the things you'll want to do for that is look at your plant growth, and you will apply the fertilizer to the sides of your plant or around the base of the plant, but away. And most of the fertilizers that we would apply during the middle part of the season are usually going to be nitrogen. It's not usually going to be a lot of phosphorus and potassium. Usually it would be a low level nitrogen, usually it's something of a 5 or a 10% value.